So this is an example of a linear equation. X plus 3 is equal to 8. So we know it's an equation because it has an equal sign. It has two sides, the left-hand side and the right-hand side. And this equation is telling us that these two things are equal. So when you have an equation, what's nice about working with equations is that you can do anything you want to, so long as you do exactly the same thing to both sides. And that's a key to solving pretty much any type of equation. So in this equation, I just want to get x by itself. I'm going to have x equals something. So I want to get that x by itself. I want to get rid of that plus 3. I undo a plus 3 by subtracting 3. So I'm going to take the left-hand side of that equation. There it is, the left-hand side, and I'm going to subtract 3. Which means I have to do the exact same thing to the right-hand side of the equation. So x plus 3 minus 3 is just x, and 8 minus 3 is just 5. And if you plug that in back to the original equation, you get 5 plus 3 is in fact equal to 8. So I know that this is correct. So this idea of having two things that are equal to one another, and there's the equal sign in this equation, you can do anything you want to both sides, as long as you do exactly the same thing to both sides. So for example here, I could, if I wanted to, subtract 2z from both sides. So if I subtract 2z from this side, I'd have 2z plus 1 minus 2z, that's just going to be the 1, and 10z minus 2z is 8z minus 1. So this time I didn't write it down. You write it down or not, just depending on how comfortable you are with it. I tend to not write the steps down if they're fairly simple, and I do write them down if they're complicated. So I'm going to add 1 to both sides. I can do 1 plus 1 in my head without writing it down. That's 2. And I can do 8z minus 1 plus 1 in my head, because that's just going to be 8z. And then I'm going to divide both sides by 8. If I divide 8z by 8, I just get z, and this needs to be reduced. So this reduces to 1/4 is equal to z. So this, I think, is my solution, but before I am completely satisfied that it's the solution, I'm going to check. So I'm going to plug into the left-hand side of the equation, which will give me 2 times 1/4 plus 1. So I'm plugging what I think z is in here for the z on the left-hand side. That would give me 2 times 1/4 is 1/2 plus 1 is 3/2. And the right-hand side, I'm going to plug in 1/4 for z, so that would give me 10 times 1/4 minus 1 is 10/4 minus 1 is 5/2 minus 1 is 3/2. So the left-hand side and the right-hand side evaluate to the same thing when I plug this in, and so I know that it's correct because 3/2 is in fact equal to 3/2. So let's do a few more examples. These linear equations, they can get complicated, but they can't really get much more difficult than what we've done there. So you can have lots more terms. Another thing you can always do, like we did here, we did the same thing to both sides here, and every step of the way here we're doing the same thing to both sides. The other thing you can do with equations is you can always work with one side or the other as an expression and do what's already in there. So like here I have a 5d minus 4d. I can combine like terms there and just get the d plus 9 is equal to 51 minus 5d. So in this step I didn't use the power of that equal sign, but now I'm going to add 5d to both sides. Then I'm going to subtract 9 from both sides. So that would be 42. Okay, I'm not very good at arithmetic here. And then you divide both sides by 6, and you're going to get d equals 7. And then I would plug that in and check. And I would plug in right into the original equation before I manipulated it all. So the left-hand side is equal to 5 times 7 plus 9 minus 4 times 7. So this would be 5 times 7 is 35 plus 9 minus 4 times 7 is 28, which is equal to 35 plus 9, let me do it, 44 minus 28 is equal to 44 minus 20 is 4 is 16. And the right-hand side would be 51 minus 5 times 7, which is 51 minus 35, which is 2016. Good. So that works. So this was a little bit more complicated, but we solved it and checked it and we got it right. So after you check it, you know that it's right. Another thing that can happen with linear equations is your variables can be stuck inside of parentheses. So if you had, say, 4 times b minus 5 equals 44. If you want to solve this for b, solve for b. I'm going to solve this two different ways, because you got to get that b out of that set of parentheses. One way to go is to perform the multiplication and use the distributive law here. So you'd get 4b minus 20 equals 44. And so you'd have 4b equals 64. Add the 20 to both sides. Divide both sides by 4. And you get b equals 16. That's one way to go. Another way to go, because what's happening is this set of parentheses is being multiplied by 4, you could divide both sides by 4, and you get b minus 5 equals 11. Add 5 to both sides, you get b equals 16. And so probably b equals 16 is right. You should plug in and check, and it's actually not difficult to plug in and check, because if you plug in b equals 16 in here, 16 minus 5 is 11 times 4 is 44. So we know that this is right, and that was two different ways to go. And that's generally the case with equations, is you got more than one way to solve them. And so let me just do one more. Bear with me here. So here we have our variable stuck on both sides of the equation, both stuck inside of parentheses. If I tried to divide through by 7 here, like I divided by 4 here, the reason this worked out nicely was because 44 is divisible by 4. But, you know, if you divided both sides by 7 here, you get a 5/7. If you divide both sides by 5, you get a 7/5. So I'm going to do the distributive law here and here. And then I'm going to solve, and I'm going to show you can do two things at once. So I'm going to subtract the 5x from both sides there, and I'm also going to subtract the 14 from both sides there. And then divide both sides by 2. And you get x equals 3, and you should plug in and check here. And you can see that this is correct, because you get 7 times 5 if you plug in there, and 5 times 7 if you plug in there. So that's solving linear equations. Okay, very good.